Welcome to this Skill Builder session on mixing solutions. In this session, we'll be looking firstly at how to calculate the final strength of a mixture of two or more different strength solutions. Then we'll look at how to mix two different strength solutions in order to obtain a final desired strength and volume using the alligation method. The session is intended primarily for biology, chemistry, and medicine and pharmacy students. In the first example, we're asked to calculate the final strength of a mixture of two quantities of two different strength solutions. In order to solve this question, the first stage is to calculate the amount of active ingredient in each solution. Thus, we have firstly 10% of 60 millilitres, which gives us 6 grams of sodium chloride. Secondly, we have 20% of 100 millilitres, which gives us 20 grams of sodium chloride. We can now add the two amounts of sodium chloride and the two total volumes. Hence, we have 6 grams in 60 millilitres added to 20 grams in 100 millilitres, giving us a total of 26 grams in 160 millilitres. We can now use a proportional set to convert this to a percentage. 26 parts over 160 parts is going to be equal to x parts over 100 parts. Transposing for x, this gives us 26 times 100 over 160 for a final answer of 16.25% weight in volume. In the second example, we're mixing a part strength solution with a percentage solution. As before, the first stage is to calculate the two amounts of active ingredient. Hence, 1 part in 25 times 150 millilitres gives us 6 millilitres. And 12% times 150 millilitres gives us 18 millilitres. We can now add the two amounts and the two volumes to give us a total of 24 millilitres in 300 millilitres. No need to use a proportional set here. We can simply divide the top and the bottom by 3 to give us 8 millilitres in 100 millilitres, 8% volume in volume. Pause the video here and, using the same method, calculate the correct answer to the question. Once you've finished, resume the video to check your answer. In the second part of this video, we'll look at how to calculate the quantities of two different strength solutions required to mix to create a specific volume of a specific strength solution. To do this, we'll be using a very useful illustrative technique called alligation. Alligation uses a grid like that of noughts and crosses, or tic-tac-toe, 3 rows and 3 columns. We can then start to populate the grid with our values. In the top left, we put our high strength solution, and in the bottom left, we put our lower strength solution. Then, in the centre box, we put our desired strength. We can then perform subtraction diagonally up and diagonally down. All that we need to remember here is that we need to be dealing with positive numbers. Therefore, in the top right-hand box, we're going to have the desired strength minus the lower strength. And in the bottom right-hand box, we're going to have the higher strength minus the desired strength. This will then give us the number of parts of the higher strength solution we need to mix with the number of parts of the lower strength solution to give us the final desired strength and volume. So we'll now try using the method to solve an actual question. In this case, we're going to calculate how much of a 70% solution and how much of a 20% solution we need to mix in order to produce 200 millilitres of a 30% solution. First stage then is to draw our grid. 3 columns, 3 rows. Now that we have our grid, we can input our strengths. Higher strength at the top, 70%, lower strength at the bottom, 20%. And our desired strength, 30, in the middle. We can now perform our subtraction diagonally. The desired strength minus the lower strength, 30 minus 20, giving us 10. And then the higher strength minus the desired strength, 70 minus 30, giving us 40. We can now reduce this by a factor of 10 by cancelling off the 2 zeros. This gives us 1 part of 70% solution added to 4 parts of a 20% solution. And since 1/5 of 200 millilitres is equal to 40 millilitres, this is going to give us final volumes of 40 millilitres of a 70% solution mixed with 160 millilitres of the 20% solution. Now pause the video here to try solving this question using the alligation method. Once you've finished, restart the video to check your answer. Thank you for watching this Skill Builder session on mixing solutions. If you'd like to follow up on any of the topics covered, please follow the QR code to book a one-to-one appointment with either a student learning advisor or, for support with more advanced topics, our Maths and Stats clinic.